Designing a 3D model and carve it out with a CNC router? Fortunately, it's not mission impossible, or at least not as hard as it may seem. And once you made it, you will probably have a great eureka moment. So today, we have this newbie's guide on 3D modeling and CAM setup for Fusion 360, and we'll show you how to create your designs with the Snapmaker 3-in-1 3D printer, step by step. The video is divided into two parts, CAD and CAM, namely computer-aided designing and computer-aided manufacturing. The first part is about sketching and creating a solid body. The second part will cover the basics of importing tool library, setting 2D pocket, setting 2D contour, and post-processing. And in the step of setting 2D contour, we will share some useful skills like setting tabs between model and stock, as well as cutting off material in several rounds. For the information of software, machine, and material we use here, you can refer to the video description below. And note that to prevent the CNC bit from running into the machine's clamp sets, make sure the size of the material is large enough. To demonstrate some of the basic Fusion 360 modeling principles, we'll create a simple and expandable desk organizer. We generally start off by creating a sketch that defines the basic geometries of a 3D object. Since we want to make a hexagon container, we should draw a hexagon first. Click on Create Sketch and choose where you want to draw the hexagon. Open the drop-down menu of Create and select Polygon, Circumscribed Polygon. Use the coordinate origin as the center and draw a circle of any size. Now we have a hexagon. Sketch Dimension helps us adjust the size and position of a sketch object. Select it in the toolbar or simply press D key. Left-click on the side of the hexagon. Move the mouse and left-click again so we can adjust the length. Let's set it to 42 millimeters. But this might change the direction the hexagon is facing. To make the following steps easier, we can draw a horizontal line and click Parallel on the toolbar to make the hexagon side parallel with the line, so that the hexagon faces the right direction. Then we can select the line and delete it. Here comes a key point. In 3D modeling software, there is usually no shortcuts or a tool that can give you a shape or form that you want magically. We need to utilize a combination of basic shapes offered in the software and modify them to the desired shape or form. And in this video, we will design some mortise and tenon joints so that we can connect two pieces of organizers easily. We can use circles to create the mortise holes and tenon tongues. Select Center Diameter Circle or press C key and make a circle right above the hexagon with a diameter of 8 millimeters. We call it Circle 1. Use Sketch Dimension again to shorten the distance between the center and the hexagon to 6 millimeters. Now draw Circle 2 next to Circle 1 with a diameter of 4 millimeters. Select Fix Unfix in the toolbar and fix Circle 1. Next, choose Tangent on the toolbar and make Circle 1 tangent to both Circle 2 and the hexagon. When finished, we can use Mirror to copy Circle 2 to the right side of Circle 1 instead of making another one. Draw a vertical line through the center of the circle. Choose the Object and Mirror line and hit OK to get Circle 3. Obviously, there are some parts we don't need in Circle 2 and Circle 3. Select Trim on the toolbar or press T key and click on the unnecessary parts to remove them. To copy the tenon structure to other sides of the hexagon, we need to use Circular Pattern. Choose the object and center point on the pop-up menu. Type in number 3, and there will be another 2 tenon sketches. And what about the mortise? Still, we can use Circular Pattern. But this time, we should select Angle as the type, with a total angle of 60 degrees and a quantity of 2. Use Mirror to flip the tenon, and that's how we make a mortise structure. Finally, copy the structure to other sides of the hexagon, and we are done with the sketching part. Once we have a 2D sketch, we can expand it into a 3D object. Select Extrude on the toolbar, or press E key. Check the parts we want to extrude and input the offset. To make sure the wood board can be cut through completely, we can put in a number that is slightly larger than the actual thickness of the material, such as 10.5 millimeters. A body is created then. Technically, no machine can hold dimensions precisely to the nominal value. There is usually a deviation of 0.2 millimeters to 0.5 millimeters during the processing of an ordinary CNC router. And that's what we have to keep in mind when designing a model. Leave some space for potential machine deviation. If we forget to resize the mortise and tenon structures, it's very likely that the finished products can't be connected well with each other. Select Offset Face under Modify. Select the faces of the tenons and set the offset distance to -0.2 millimeters. In the same way, adjust the mortise faces too. Extrude function also allows us to set pockets in specific shapes and sizes on solid bodies. Here, we are going to create some holes for placing ER11 collets and nuts, as well as 1.5 millimeter flat end mills. Now that we are making a container, it's necessary to measure the sizes of the items you are going to put in the container. Create a sketch. Draw two concentric circles with diameters of 10 millimeters and 20 millimeters respectively. And draw another circle with a diameter of 3.5 below them. As you may have noticed, the circles we made are a little larger than the actual objects. Next, we can copy the circles using circular pattern as needed. When it's done, finish the sketch. Finally, extrude the circles to a certain distance, which is -1.5 millimeters for three largest circles, -6 millimeters for three smaller ones, and -5 millimeters for six smallest ones. Now we have finished the CAD part. When we complete the design, we can enter manufacture mode and move on to the CAM part. But if it's the first time we are doing CAM in Fusion 360 and use a Snapmaker machine to carve it out, we need to add the bits profiles of Snapmaker to the software's tool library first. And by adding the bits profiles, we can save a lot of time on setting a new tool on our own. Download configuration files for Fusion 360 from the support page of Snapmaker official website and extract them. Go back to Fusion 360, go to Manage, Tool Library, and go to Local Library. Right-click on Library, select Import Tool Library, and import the extracted tool file corresponding to your machine model. Now, let's create a new setup. A setup tells Fusion 360 how a piece of stock is positioned on the bed of the CNC machine by specifying a coordinate system and an origin for the stock. Choose Orientation, select Z-axis, Plane, and X-axis on the pop-up menu. Make sure the Z-axis of the model and the software's coordinate system are in the same direction, so that the surface to be carved will face upwards when milling. Open the Stock tab, select No Additional Offset as the Stock Offset mode, and click OK. The next step is to tell Fusion 360 what to do, and where to do it. To make such type of round holes, the 2D pocket would be a good choice. Before choosing a CNC bit, imagine how the carving process is going to be like. In this case, we picked the 1.5 millimeter flat end mill that can carve flat surfaces and slots that have sharp corners. Spindle speed and ramp spindle speed can be set at 12,000 RPM, which is the most efficient working speed for Snapmaker CNC module. Next, open Geometry tab. Select the circles to be made into pockets. And in order to get a smooth surface, we need to narrow the gaps among the tool paths. Open Passes tab and reduce the maximum step over to, for example, 1 millimeter. Anyway, it should be at least smaller than the cutting diameter of the CNC bit. To make sure the pocket walls will be carved precisely, it's very important to uncheck the Stock to Leave or set it to 0 millimeters. Because if we don't, the default is 0.5 millimeters. Stock to Leave will make the actual carved pockets 1 millimeter narrower than we would expect. And this is how it works. Now, we need to tell Fusion 360 how the contours should be cut. Select 2D Contour, and we can see the tools set up already. So, just open the Geometry tab and select the bottom contour of the model. Here's another tip. Adding a couple tabs around the part to hold it down on the stock during the manufacturing process. Check Tabs. Set tabs automatically by distance, or select At Points to do it manually. For the latter, left-click on the bottom contour of the model to set tabs. Finally, the cutting edge of the 1.5mm flat-end mill is shorter than the material thickness of 10mm. To ensure safety, it's important to prevent the shank from touching the inner wall when the bit is moving inside the material. Select Passes tab, check multiple depths, and set the maximum roughing step down to 2mm, for example, so that we can cut off the model in 6 rounds. When everything looks good, hit OK. Hold Control key to select both setup profiles and go to Actions, Post-Process. Select the extracted folder as Configuration folder, name the project, and click Post. Fusion 360 will then translate all the toolpath information into G-code that is readable to a Snapmaker machine, and give you a G-code file with a CNC extension. Once we have a G-code file, we can import it to a Snapmaker 3-in-1 3D printer with the CNC module installed to start processing. Before operating the machine, be sure to read the product manuals or watch the CNC video tutorials to learn about all the safety information. When setting the CNC carving on the machine, always use the run boundary function to avoid collision between the CNC module and other parts of the machine, including clamp sets. Okay, that's all for the tutorial. Let's turn on the machine now. We can also easily make a phone holder, a USB flash drive organizer, and put them together into a set. We are going to share more tips and tricks for 3D printing, laser engraving, and CNC carving in Snapmaker Academy. If you like this video, please give it a like and subscribe to our channel for more interesting content. If you've got any questions, suggestions, or something you want to learn more about, don't hesitate to leave a comment down in the comments section below. Have fun making!